Good day everyone, my name is Champatriki Puntili. So today I'll be discussing the measures of relative position. As median, divide the sets of score into two equal parts. Versus the other measures that divide the distribution into 104 or 10 equal parts. There are the other measures of position, the percentiles, the quartiles, and the deciles. So measures of relative position in statistics help determine the location of a specific value with the data, while the median divide the data into equal parts, or other measures such as the percentile, quartiles, and deciles divide the distribution into 104 or 10 equal parts respectively. Percentiles are used to rank data by showing the percentage of value below a particular points. Quartiles divide data into 4 segments to show the spread and the center of deciles. Provide a more detailed division that quartiles. These are the measures of valuable tools for analyzing interpreting data, allowing for better comparison and understanding of how individual value relate to the whole distribution.
Hi everyone, today we're going to learn about percentile. One way of assessing performance is by the use of percent. The percentiles are the score points that divide a distribution into 100 equal parts. To find the data value for the percentile, we use the location of the data value n and the data set given by I equal n asterisk percentile over 100. To find the percentile of the particular value in the data set is given by percentile equal I over n asterisk 100. So, percentiles divide a dataset into 100 equal parts. The percentile is the value below which percent of the data sample. The 25th percentile means 25% of the data is below that value. The 50th percentile is the median, the middle value. The 75th percentile means 75% of the data is below that value. So, ang ilang formulas, 1. Finding the location of the percentile, I equal n asterisk p over 100, where? So, sa I equal the location of the percentile within the ordered data set. Sa n is the total number of the data points in the data set. So, sa p, the desired percentile. Example for the 55th percentile. So, another example, if you have a data set with 20 data points n equal 20 and you want to find the 75th percentile, the formula will be I equal 20 asterisk 75 over 100 equal 15. This means the 75th percentile is located at the 50th position in the ordered dataset. If the result is not a whole number, you all typically run off or use interpolation. So, set 2, finding the percentile from a given location I. So, P equal I over n asterisk 100, where? So, ang P, the percentile. Sa I, the location of the data point. Sa n, the total number of the data points. So, another example na sub, at the 50th data point, I over I equal 15, and the data set of the 20 data point, n equal 20 is 85, then P equal 15 over 100, asterisk 100 equals 75. Therefore, 85 is 75th percentile. That's all.
The image show defines quartiles. So the quartiles are like dividers that split a set of ordered numbers into 4 equal parts. So think of it is cutting off line of numbers into fourths. So each quartiles represent 25% of each numbers.
Deciles divide data into 10% equal part, each part representing 10% of the data. Think of it's like cutting a cake into 10 slices, each slice being a deciles. For example, first deciles, lowest 10%. Second deciles, next is 10%, total of 20%. Third deciles, next is 10%, the total of 30%. Up to 10 deciles. So the 10 deciles is the highest 10%. It helps to understand the spread of ranking of the data.
So to find the value of the 30th percentile, we need to arrange in the data in descending order. Since we don't have the actual data, we will use a formula to estimate the 30th percentile. So the formula for the KPH percentile is L is equal to K over 100 times N plus 1.